This is URK 19C1093 experiment number 7, conditional memory allocation. So in this we have to use three techniques: worst fit, best fit, and first fit. So let's see the code. So first is worst fit. So here first we are creating a function to allocate memory to blocks as per the worst fit called worst fit, and inside that we are passing arguments block size array, then integer n, then process size integer array, and integer variable n. Then to store the block id of the block allocated to a process, we are creating int allocation of n. Then to initially no block is assigned to any process, so it's given as memset allocation -1 size of allocation. To pick each process and find suitable blocks according to its size and assign to it using a for loop. Then to find the best fit block for current process, we are initializing int first idx equal to -1, and using a for loop we are creating int j equal to 0 i less than m j plus plus. And if block size of j is greater than equal to process size of I, then if worst idx of equal to -1, then j's value will be stored into worst idx, or else then block size of worst idx is less than block size of j, then j's value will be stored into worst of idx. And if we could find a block for current process, then we use another if loop where worst idx not equal to -1. And then to allocate block j to p of I process, we'll initialize worst idx value into allocation of I. Then to reduce the available memory in this block, we'll decrement the block size of worst idx with process size of I. Then we are printing the process size and block number using a for loop I equal to 0 I less than n I plus plus. We are printing I plus 1, then process of size of I in each position. And if allocation of I not equal to -1, and allocation of I plus 1 will print, or else if this condition is not true, then it will print not allocated. And inside the main block we'll give the block size and process size, and this is the m and n will contain the size of block size by size of block size of 0, and n will contain process size by process size of 0, and it will call the function worst fit. So let's see the output. So this is the values for block size and process size. So the process number is 1 2 3 4, and process size for each is given here, and block number is there, but then now the process number 4, for that block number is not allocated. So this is the worst fit. Next is first fit code. So in this also we are creating a function first fit. Inside that we'll have these arguments, and inside that we will initialize allocation of n, then memset of allocation -1 size of allocation. Then using a for loop we'll do int I equal to 0 I less than n I plus plus, for int j equal to 0 j less than n j plus plus. And using an if loop we'll check whether block size of j is greater than equal to process size of I. Then if that is true, then allocation of I is equal to j, and process size of I will be decremented with block size of j, and we'll break it, and we'll print the process size. And using a for loop I equal to 0 I less than n I plus plus, we'll print the value is I plus 1 and process size of I. Then using an if condition, if allocation of I not equal to -1, then we'll print allocation of I plus 1. If this condition is false, then we'll print not allocated. And inside the main function, we'll print the values of block size and process size, and then we'll get the m and n, that is the size of block size by size of block size array of 0, and then size of process size divided by size of process size of 0, and we'll call the function first fit. Now let's run the code. So here also here the block number has changed from the worst case, and here also the process number 4 has no allocated the block number. Next is best fit. In this also, same as both those code, we are creating a function best fit these arguments, and then we are creating an integer allocation of n, then set allocation -1 size of allocation. Using a for loop, we are giving I equal to 0, I less than, and I plus plus. Then we are using the best id x equal to -1, and using a for loop, we are giving j equal to 0, j less than m, j plus plus. Inside that, using an if condition, we are checking whether block size of j is greater than equal to process size of I. That condition is true, then best idx equal to -1, best idx equal to j. Else if block size of best idx is greater than block size of j, then we'll put j's value into best idx. Coming out of it, we go for the if condition. If best idx not equal to -1, then we'll initialize the best idx value into allocation of I, and process size will block size of best idx will be incremented from process size of I, then it will print the process number of process size and all, block number and all. And using a for loop, I equal to 0, I less than, and I plus plus, we will print those values. And using if condition, we'll check whether allocation of I not equal to -1. If that is true, then it will print allocation of I plus 1. If this condition is false, then it will print not allocated. And inside the main function, we'll print those will give those values for block size and process size, and then m and n for the size of block size by size of block size of 0, and then size of process size by size of process size of 0. Then we'll call the function best fit. Let's run this program. So this is the output for the values are given, and this is the output for the best fit. So there is no not allocated thing in this table. That's all. Thank you.